Well, I had a, I guess it was a crash. I was going to say a bit of a crash. I didn't have to tram the head originally. It was accurate. But in the last 2 days, I've had to, this is going to be the third time I've had to tram it. Okay, so I was making the inner bearing adapters, okay, and haven't had huge success yet with it or whatever, but so I had this mounted up in here and it was taking a heavy enough cut, and basically it was 50 thou off the diameter, so it was a 25 thou deep cut. RPMs were looks like RPMs were I got 1600, and it was 8 thou per revolution. Now for the cutter I'm using, for the tip insert I'm using, 0.08 or the 8 thou, that's half of the radius, because this is a 4 millimeter, 0.04 millimeter, 0.4 millimeter, I don't remember. Anyway, it's 0.0156. So it's basically considered 16 thousandths radius, okay? And from everything I was reading, you don't want to go less than a half, okay? 1600, I'm not quite sure exactly where that came up from. Anyway, it was working fine. I loaded in, I had it set up and was turned two pieces yesterday, and they came out great. And I was like, oh, finally. I had one or two things to tweak. And came out here this morning while I loaded up the other program. Very similar, but I hadn't made some of the same changes to it, so it wanted to do a 50 thou cut instead of a 25 thousandths depth cut instead of 12 and a half or 13 or whatever I run on the most recent. Anyway, so I figured I'd share this with you. This I did spin on the jaws just a little bit there. It stalled the chuck. It stalled the spindle, okay? And I mean completely. It stalled the motor. When it was taking the cuts, because I did run one piece that came out okay, and it's kind of hit and miss on that 25 thou depth of cut. It ran it really nice on the last one, but then on this one it decided, nope. So what it does, I think it runs it like about 80% of the spindle torque load according to the power drawbar panel, and it slows it down enough, and then it finally just stalls it. Okay. Well, so there, it's a CCMT insert, and I thought you guys might get a kick out of, maybe not so much a kick, but I was pretty damn impressed with that. It stalled the spindle motor. This is 1020 DOM steel tubing. Stalled the spindle motor, but it did not stall the servo. Look at that friggin' chunk of metal. I mean, look how deep that is. That's every bit of 25 thou deep. Obviously, yeah, because that's where the cut was. And it just shoved it. You can see the little waves in the bottom there. You can see how much of the metal has just been pushed up. I mean, just like shearing. I mean, that is just, wasn't cutting. It was just friggin' pushing it up there. So, it hurt the insert. Normally what I've been doing is I've been setting the parallels under here and then taking the parallels out. Okay, so that, because this has happened before, and it would just push the tooling down. Okay, and then I just lift it back up, put the parallels under it. Well, I left the parallels in this last time, and it's down hard on the parallels, which is why it took the big chunk out of the metal, because it had no place to go. So, and in pushing down, it actually, considering where we're at, I mean, we were what, an inch? This an inch and an eighth maybe, because this started as 2 1/4. off center. Okay, so in just over an inch of leverage, it created enough downforce on that to push this, to push the head out of tram. Not a great deal, but enough you can see it, and enough that I'm going to have to friggin' deal with it. But that's actually pretty damn impressive at just how much force that servo generates. Man. Yeah, quite impressive.